Okay, so in this video, we'll talk about classful addressing. So already we have discussed that to provide a unique identity to each of the nodes uh, in the network which want to communicate, we are assigning one identity, which is the IP address. So here we are talking about first IP version 4, which is comprised of 32-bit address. So the total address space is 2 power 32. So address space means that how many addresses can be generated out of 32 bits. So this is said to be address space. So initially, when we come up with the idea of IP, we have assigning the blocks through one technique called classful addressing. And later, we have realized that there are certain drawbacks or limitation with this addressing technique, and we move to classless. So when we move to the classless, then classful becomes a part of the classless or very small part of classless. So still it was there. Presently, we are using classless, and now classful just becomes a very small part of classless. And we have move to a flexible addressing technique. So let's understand what is classful. So this is the total address space uh, of the IPv4 addresses. So in the classful addressing, we have distributed the overall address space into certain blocks. So you can realize like this. Let's say this is your total space, address space 2 power 32 addresses. And then we divide this total 2 to the power 32 into two parts. So this becomes 2 power 31. So that means the total space has divided into two parts, which is 2 power 31 here and 2 power 31 here. And then we further divided this 2 power 31 space into two equal halves. So this comes out to be 2 power 30 and this also 2 power 30. Now these many addresses were further divided into two parts. That comes to be 2 power 29 and 2 power 29. And then we further did the same thing. So this becomes 2 power 28 and this becomes 2 power 28. So actually this division has given a name. This is said to be A, or we are calling it the class A, class B, C, D, and E. This is how the entire address space is divided into A, B, C, D, and E. So let's see. So here you can see this is how the classes have been defined into A, B, C, D, and E. We have seen, and this is how this is their allocation. So you can see the class A has 2 power 31 addresses, which comes out to be somewhere 2 billion addresses, which is 50% of the total address space. So this is 50%, then this is 25%, this is 12.5%, and this two is 6.25 and 6.25. So this is how the entire address space has been distributed. Now let's understand that how the entire division has actually been given. So we have seen that in the IP version 4, that 32 bits have been represented in the 4 octet. 4 octet means as a combination of 8 bits. So 8 bit, 8 bit, 8 bit, and 8 bit, that makes 32 bits. So now understand. So we have set one bit 0, and the remaining, this is the first octet, second octet, third octet, and fourth octet. So if I set first bit 0, then we just look to all the combination that we can have with the 0 bit. This is actually the half of the total possible combination. So we have 0 fixed bit, and then the other 50% is this 1. So you can see this is the first half with 0 bit set fixed, and the other half is where 1 bit is fixed. Now you can divide this or look in this context of A, B, C, D, and E. So this half 50% is divided into A. And then further we have divided the next 50% into two equal halves, 25 and 25%. So now we are keeping 2 bit. So we have keeping 1 0 and 1 1. This makes the two further uh, kind of a partition among that 50%. So this is basically class B. And then we keep on doing like this. Then from this we may another 50% is 1 1 1 and 1 1 1. We keep 3 bits set here. So this becomes class C. And then to this next portion, we will further dividing into two equal halves to 110 and 1111. This is D and E class. So this is how we have, uh, you can say, distributed into A, B, C, D, and E. And also you can see here, now we need just 4 bit to realize that to which class this address belong. So if any address is given to you in the form of binary, you need to just read the 4 first bit and then we can find out. So if the first bit is 0, this is class A. If then it is 1 and 0, this is class B. Similarly, if it is 1, 1, 1, 1, we can say this is class E. So easily we can find out to which class this address belongs to. Okay. Then next thing is, now just focus on the first octet. So we have 4 octet in this 32 bits. Now when we say class A, so let's say class A and just look to the first octet. We know that the class A here, this 0 is being fixed here. So in the first octet, we are left with 1, 2, 3, 4, 5, 6, 7. We have 7 bits are remaining. And here in 7 bits, we can make all possible combination. So the first thing is, let's say we write all 7 zeros, and we can make 1001, and then so on. We can make the last combination is, we can keep all this all 1. So when you look at this, this is actually 0. And when you look at this 0, 1, 1, 1, 1, 1, 1, this is 127. So this tells us that A goes from 0 to 127. Now look to the B structure. Now in the B, we have 1 0 is being fixed here, and then we are left with 6 bits in the first octet. So 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. And now we will see what possible values can be generated with this combination. So let us keep all this 0, 0, 0 to all the 6 bits, and then the last you can also keep all this as all 1. So this will be ranging from 128 to 191. Let's look to this class C distribution. We have 1, 1, 1, 0. 3 bits are set. 1, 2, 3, 4, 5 bits can be make all possible combination. We can start with all 0 and go up to all 1, and this will be 192 to 223. So I think, let me make you clear, when I said 223, this is actually 110, and this 1, 2, 3, 4, 5. And if you do this, this comes out to 223. That means this is 1, this is 2, this is 4, this is 8, 16, this is 32, 64, and 128. So when you add all this, this comes out to be 223. Now look to the D. So D class, we have 1, 1, 1, 0. This is 4 bits have been fixed. We have 1, 2, 3, 4 bits are possible here. You can make all the combination, and this comes out to be 224 to 339. And finally, let's look to the E class, which has all four bits have been set to 1, and then we have 4 bits remaining in the first octet. So you can just make combination keeping all 1 0 and all 1. This will be 240 to 255. So you can see here 0 to 127. You can see here 0 to 127 for class A, 128 to 191. And this is already, we have seen how this value is coming and what does it represent. So what does it mean? It means that when any address is given to you in the decimal notation, we can look to the first octet and we can easily find out that the address is from which class. Now, for example, if any address is given to you, let's say the address is 223.1.2.3. So we can look at the first octet, and this is 223. So 223 falls where? Here. So that means this is from class C. Similarly, if any address is given to you like this, uh, 11001111 means in the form of binary, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to all 32 bits are given to you in the form of binary. You need to just look to the first 4 bits and we can find out. So 110, we can just look at here, and this is class C. So by looking to the first 4 bits, if the address is in the binary, or look to the first octet value, and we can find out to which class this belongs. So you can see here, this is how the entire thing has been defined, and we have understood this. So uh, if we want to find that to which class the address belongs, the software can read just 4 bits and can easily identify to which class it belongs. So you can see if the first bit is 0, it's class A. If the if it is 1 0, it's class B, and so on. So only first 4 bits are required to find out which class this address belongs to. So this is for your practice. You can check yourself that this address from which class. As I said, that just read the first 4 bits and we can find the answer. So this is the answer. You can look at it and cross-check your understanding. Similarly, this is given in the decimal form. You can just look to these questions and check your understanding. This is the answer. Now let's talk about two-level addressing. So initially, we have seen the first label that is defined into 32 bits. So we are talking about just 4 octets and 32 bits. Now, these 32 bits have been defined into two parts. We are calling as a two-level addressing. The two parts are known as network ID and host ID. Network ID will define you the network information, and host ID will tell you the size of the network. Network ID will also tell you how many networks are possible. So here, network ID is defined by N, and the remaining from 32 is a host ID. So total bits is 32. So if N is given to you, we can find out the host ID. So in the classful addressing, we have only 3 possible values for N. N can be 8, N can be 16, N can be 24. So that means if you want to write the combination, so for class A, we have the combination 8 plus 24. That means, and this is network bits is 8 and host bit is 24. For class B, it is 16 plus 16, and for class C, it is 24 plus 8. So this is how we can define the class structure. When we were doing with the classful addressing allocation, so only A, B, C is being used to assign the blocks, means all the networking and the block configuration is to be done from class A, B, and C. The class D means this entire address space, means that the entire address which comes in class D is used for a definite purpose. We are calling it a multicast addressing. And class E is also reserved for doing some kind of experiment, or it was that time realized that this set of IPs can be used for future or for some for experimentation purpose. Now let us understand what does this slide represent here. Now, so we have seen that class A. Let us start with class A. Now, class A, the nomenclature is 8 plus 24. Now, 8 is a network bit and 24 is the host bit. Now, network bit will tell you the number of network that can be created. So you can see here 8 bits are there. So in the class A, we have, so just have a look here. We have 1, 2, 3, 4. We have 4 octets are there. So in the class A, this first octet is for the network part, and this 3 octet is for the host part. So network ID and host ID. Now, network ID in this class A, the 1 bit is actually fixed here. Already we have discussed that the first bit is 0 here. So out of 8 bits, we are left with 1, 2, 3, 4, 5, 6, 7, 1. That means 2 power 7 combination can be made. So this is the number of network that you can generate. And the host will tell you the size of network. That means 2 power 24. What does it mean? It means in the class A, we can make 2 power 7 networks, and each network will have 2 power 24 number of IPs. So if we talk of class A, we have first network, second network, third network, fourth network, up to we can have 2 power seventh network, and number of IPs in each network will be 2 power 24, 2 power 24, and so on. Likewise, if we talk about class B, so class B you can see, so class B is 16 plus 16. So if you, so let me clean this part. So if you look at this 4 octet 1, 2, 3, 4. So out of 4 octet, this is a network part, and this is your host part. So out of 16 bits, the class B is defined by using 1 0. That means out of 16, we can have 14 bits are remaining here. So we can have 2 power 14 combination, that, and the size of each network is 2 power 16. So you can also see here, class B we are talking, this is the leading bit, and number of network can be 2 power 14, and we can have 2 power 16 will be the size of the network. Then coming to class C. So when I say class C, the distribution is 24 plus 8. So 1, 2, 3, 4. So out of 4, this 3 is for the network bits, and this last octet is for the host bits. So this is 24. Class C is defined as 1, 1, 0. That means out of 24, 3 bits are reserved. We can have 2 power 21 combination. That means we can have these many networks in class C. The size of each network is 2 power 8. So you can see here, this is leading bit. 2 power 21 networks can be possible. And the size of the network is 256. Now you can see here, this is 254, this is 256. Why? Because here it is says number of supported host. So we have two things uh, to be taken care. One is set number of IPs, which is the size of network. Okay, we can say number of IPs or size of network. It is the same thing. And when I say number of host, so number of host means how many IPs can be assigned to connect the different nodes. So in general, when we talk about any network, whatever the size of the network is given, you subtract the two. So let's say the size of network is, for example, is 16, then the number of hosts will be 14. We have to subtract 2 from the given range, and that is the number of hosts possible. Now, why we are subtracting 2? Because in every network, the two IPs are reserved for a particular purpose. The first IP of the network and the last IP of the network. The first IP is the IP that represent the network. It's called a network address. It represent the network. And the last IP is basically is a broadcast IP, which is called a directed broadcast IP. So out of the total IPs given in the block, we have to subtract 2. So similarly, we have here 2 power. So if I say how many hosts are connected, so the correct answer is we have 2 power 24 minus 2. Here we have 2 power 16 minus 2. Here we have 2 power 8 minus 2. And we are only using class A, B, and C for designing our network. Class D and class E is actually reserved for a different purpose. So now if we want to extract the information in the classful addressing, so if you want to find the first address and the last address in the class. So what is required? You can keep all the, so if, let me write here, if you want to find the first address, then we keep uh, the host ID bit to all 0, and for the last address, the host ID bit to all 1. So when you keep all means 8 bit, if you keep all 1, 1, 2, 3, 4, 5, 6, 7, 8, it comes out to be 255. What does that mean? Let us take with an example. So you can see here, the first address, we can keep all the host ID bit 0, and for the last address, we keep all the host ID bit 1. Okay, so now let's understand how the addresses have been defined in class A. Class A, when we say the class A will go from 0 to 127 we have already discussed. Okay, and so we are looking for the only first octet. So class A means this is 8 plus 24. That means 8-bit is for the network ID and 24-bit is for the host ID. So you can see this 1, 2, 3, 4 octets are here. Now here the value goes from 0 to 127. That means you will keep here 0, and with 0 you can make all the combinations 0, 0, 0. This is your first ID in the class A with 0 network. And then you can keep all this 1, 1, 1. That is 255, 255, 255. So this is your first block. Okay, first block in class A. You can see here. Then second block is 1.0.0.0 and then 1.255, 255, 255. This becomes your second block. Likewise, you can go to the last block, which is 127.0.0.0 and this. So you can easily find out how these blocks have been represented. Now let's have a look on class B. Class B, when you say, so class B means this is 128 to 191. So you must be knowing the range of class B and also the allocation. So here we have 16 plus 16. That means this 2 octet is a network ID and this is the host ID. So the first address when you want to find out, so you can see it goes from 128. So we will write here 128.0.0.0. Okay, and the last address is 128.0. So means if you look at this, this is your host part. So the host part, all bit 0 is the first address and all bit 1 is the last address. So 255 to 55, this is the first block in class B that starts from here and goes to this. Similarly, if I want to find the second block, so this is means the next block, it is 128 dot 1 dot 0 dot 0 and 128 dot 1 dot 255 dot 255. Likewise, if you go to the last block, so it goes up to 191 dot 255 and dot 0 dot 0 and 191 dot 255 dot 255 dot 255. So this is your the last block in class B. Similarly, if we want to look for the second last block, so you can see here, this is the last block. So second last block should be like this: 191.254.0.0 and 191.254.255. So this is the second last block of class B. Let's look to the class C blocks. So class C is defined in the range 192 to 223 and the distribution is 24 plus 8. That means out of 4 8, 3 is for the network ID and this is for the host ID. So we start from 192.0.0 and dot 0. So this is your network ID, this is the host ID. So the first address is this, the last address is 192.0.0 and 255. This is your last address. Similarly, second block will be 192.0.1.0 means the first address and 192.0.1.255 will be your second block in class C. Likewise, if you look to the last block, it goes up to 223. So 223.255.255.0 and it will be 223.255.255. Now see, this is your network part. So in this block, if you want to get the first address, the host ID will be all 0 and For the first address and the last address is all one. So this is going to be your last block. So I think you have understood that how these blocks have been kind of configured, the first address and the last address. So let's move to the next part. So for class D and class E, there is no two label addressing has been defined. There is the net ID and host ID is not applicable for class D and E. It is just one full block of IPs and which is used or defined for some special purpose. So this concludes our discussion for the classful addressing. So you can see that out of the five blocks A, B, C, D, and E, only A, B, C is to be used for the address allocation. D and U used for separate purpose. D is for multicasting and E is reserved for experimentation purpose. So I hope that you have understood that how the classful addressing has been defined. Okay, so see you in the next video. Take care. Bye.